Hello everybody. Today we are going to look at the vertex form of a quadratic function, and we're going to start with our target from this lesson. And our target is to be able to create, graph, and interpret. Quadratic functions in vertex form. Okay, but to do so we need to review some of our Algebra 1 vocabulary words. First, of course, get this one, some vocabulary. We need to remember what's a quadratic function. Okay, so quadratic is just, a fancy word that says a polynomial of a degree of 2. Well, what does that mean, right? It just means that our exponent, our highest exponent that we're looking at, is a 2. So we're going to hear a lot of us say x squared a lot this year when we're working with quadratics. Okay, that's all that means. Also, we need to review vertex. What is the vertex of our graph? Okay. It's the point of symmetry. Remember, symmetry is where we have things that are cut in half. We want our face to be as symmetrical as we can, right? But this time on a graph. Okay, so we must remember quadratics graph a parabola. Okay, so it makes that U shape. And the vertex is that point of symmetry right there, where I could cut my parabola right down the middle, and one half is going to, you could fold it over. That is what symmetry is. So we can fold it over and it fits perfectly. And we call that point, instead of x, y, like we're used to, we use h and k. But still our walk before we climb. Okay, so that's our review vocabulary. So let's add one more new vocabulary word, and that is going to be vertex form of quadratic, sorry about my messy handwriting, function. Please feel free to pause this video anytime that you need, okay, if you need to back up or catch up to where I'm at. Okay. So what is vertex form? Okay, it's a formula. I'm going to write this really big. I like to write really important things really big. Okay, and it's f of x, where I'm getting all of this in here. Okay. Equals a times x minus h, close parentheses, squared. That's our clue here that this is a quadratic, looking for that power of 2 plus k. So there's a few things that we need to take note of, and I like to color code. I am a color coding person. So what we're really looking at here is that A is going to stick out. It's very important. It's going to give us some information here, but when we're looking at vertex form, A cannot be equal to 0. Okay. Next, the H is very important here, right? Because that's our vertex. So we'll be looking at that number here. You do have to be careful with the sign. Remember, the formula is telling us that this is what we need to trust. And so we need to be mindful that the sign should always be a negative here, and if not, we're going to have to do a little bit of work, okay? Or a little bit of thinking at least. And then, of course, our k. So these 3 points in this formula are going to be very helpful to us. All right, so these two are going to go together because that is my x and y, my walk and climb, but we're calling it h and k. This is our vertex, okay? Let's go ahead and add standard form. And I should have put this up here. This is a review of standard form. It's another formula of quadratics where we're looking for that ax squared plus bx plus c. And our parent function, just like your parents, you know, you have your parents and then you came along, right? So the parents came before you. The parent function is like the beginning function. So all of our quadratics have this parent function of f of x equals x squared. Again, you're seeing that exponent of 2. That's our clue. It's a quadratic. Fancy name for exponent of 2. But all of our graphs are going to start with this x squared. And we'll see what that looks like. So that means our parabola starts at our origin. Okay. So when we get into graphing, our parent function graphs here at the origin. And then, just like me, like I came from my mom and I have some things that are similar to her, but I'm still my own person, right? So I'm a little bit different. So all of them start with the parent function, but when we add things to them and we get like the child function, kind of, how we could say it, then it's going to be changed just a little bit, but you'll always see that resemblance of the parent function.